Hello, we're taking a look at increasing and decreasing functions in the first derivative test. And the idea is that when I have functions, and I'm going to write a function right here, I'm just going to draw a picture. If I have a function that looks like this, if you notice, it's increasing, and this represents the cubic function, and it's in an open interval. That's why you see the arrows here. That I have these tangent lines right here, and if you notice, this tangent line is positive, and over here this tangent line is positive. So the idea is that on increasing lines, the slopes of the tangent lines are positive. If I have a decreasing function, let's look at one like this. It's decreasing, it's decreasing. And if I take a look at the slopes of the tangent lines of there, this tangent line has a negative value. And the tangent line right here at this particular point has a negative value. So I can look at and determine whether functions are increasing and decreasing by taking a look at the slopes of the tangent line. And if you recall, the slopes of the tangent line are simply the derivatives. And so this is called the first derivative test. And we're asked to find open intervals and find critical numbers, open intervals in which we can determine whether a function is increasing and decreasing. And we're going to take a look and first of all find the critical numbers. Now, why do we look at critical numbers? Because the critical numbers, which we gain by looking at the first derivative, are critical numbers, and I'm going to say this very carefully, on the function. Again, they're critical numbers on the function that indicate in which a function is increasing to decreasing. So right here, if this is f of x, my function, right here I'm going to have a critical number where the slope of my tangent line is 0, and there's a change of direction. This function goes from increasing, hits this particular y value, and decreases. So I'm going to have a particular x value, that critical number, which is again derived from the first derivative, that indicates a switch. If you notice here, I have a function that's decreasing, turns around and increases. So again, I have a horizontal tangent, and there's a change of direction of the function. So how do we determine those? Well, we take the derivative, which in this case, if you look, my function is f of x equals x squared. And we take f of x, make it equal to x squared, take the derivative, and in this case that's 2x, make it equal to 0, and solve for x, and in this case we get 0. This right here is a critical number. Now, it does not mean it's a relative max or a min. It just means it's a critical number in which either my derivative is equal to 0 or my derivative does not exist. So I'm going to write derivative number right here. And what I do is I create an interval. Since I only have one critical number and I have no restrictions on the domain, I'm going to go from negative infinity to that critical number, which is 0. And then I'm going to go from 0 to infinity. Now I'm going to pick a test point, and that test point can be any value within this interval. I choose the easiest, which is a -1, and in this case I need one between 0 and positive infinity, and I'm going to choose an easy one, which is 1, and I'm going to take and I'm going to substitute -1 into the first derivative, and all I care is about the sign. So I'm going to have 2 times a -1. That's going to be a negative value. I don't care that the answer is a -2, I care that it's negative. And again, I'm going to take that first derivative and I'm going to plug in 1. And I'm going to get a positive here, specifically a positive 2. What does that mean? That means my function, f of x, is decreasing within that interval from left to right. And what does this positive mean? That f of x is increasing from left to right. So there was a change in direction at 0. Now if I put 0 into f of x, remember 0 is my critical number, I get 0. So I have the point 0, 0. Well, that means 0, 0. Since I switched from, remember it's decreasing and then it's increasing. at 0, right here. That means 0, 0 is a relative minimum because, now I have two choices. I can say because f of x changes from decreasing to increasing. Now that is one reason. Or I could say, or I don't have to say both, or I could say because the first derivative changes from negative to positive. I could say either one. What I can't say is that f of x changes from negative to positive, because it doesn't. Only the derivative changes from negative to positive. Either one of these are satisfactory reasons why 0, 0 is a relative min.